Hi and welcome. This is part 2 of our discussion on section 10.2, concavity and points of inflection. So in this example, well, we're going to work with an example here. We are looking at the total sales S in thousands of dollars per month, and that is related to the advertising spending X, which is measured in thousands of dollars per month, by the function given here, which is S of x is equal to negative 0.06x cubed plus 1.9x squared plus 5. Alright, now the first part of this example, we are asked to graph S on the interval from 0 up to 20. And so the way that we're going to do that is I have some screenshots of a graphing calculator, and in this first screenshot up here, we have our function typed in, and I would encourage you to take a look at this at home and make sure you have your graphing calculator, type it into your graphing calculator. And we are told that we want to have the x values between 0 and 20, so our x minimum is 0 and our x maximum is 20. And I don't care about the y values at all, because the next thing that I want to do is that I want to go over to zoom. So there's 2. In step 3, I want to look at zoom fit. So zoom fit, remember, will give us our correct y values for the given x values that we've chosen. Okay, so that brings us to our graph. So once we hit the graph, here comes our function. Great. And we might want to just take that and, draw that on the front page, but something I might also want to do is just kind of go back and double check that window again. So when I hit the window button again, then I see on the window that our x values are 0 and 20, and our y values, our y minimum is 5, and our y maximum is 285. So I can do something to make my graph a little bit nicer by changing the y minimum to be 0. And the reason that I might do that is so that I can include the x-axis, whereas if our graph starts at a y value of 5, I don't actually see the x-axis. So once I change that y minimum to be 0, then my new graph is below. And it looks almost the same, but now I can kind of see that x-axis down there kind of showing up. Okay, now we were told on our picture, we declared that 0 to 20 was our x range, and our y range went up to 285. At least that's what the calculator chose for us for our y maximum. Alright, so keeping this picture in mind, I'm going to go back and draw this function on the first page. Okay, so we have our picture on the graphing calculator, and now we're going to try and sketch that on the first page. And so we want to graph S on this interval, and the picture kind of looks something like this. Now, once I have the picture, I also want to include some labels on my axes. So along the x-axis, we have money spent on advertising. And that is measured in thousands of dollars. And on the y-axis, we are measuring the sales, which is also measured in thousands of dollars. And I remember that the graph went up to 285, so I'm going to do a little bit of rounding here and have my graph go up to 300, and then I have 200 and 100. And on our x-axis, we told the calculator to measure from 0 to 20. So once I put the 0 in and the 20, I can kind of make some marks and get some rough estimates here of 5, 10, 15, and 20. Okay, so here is our graph of S the graph of our total sales, where we input an amount for advertising and we get an output for sales. Okay. Now, before we continue and look at part 2, some observations that I might make about this particular graph is that the money spent on advertising, we can think of that as our investment. And the sales, or the output, which is what we're getting by having an investment, that sales is our return on investment. And so we have an investment, which is our input, the money that we're spending, and then we get something back, which is our return on investment. Okay. In part B, we are asked to estimate on the graph the point of diminishing returns. All right, so the point of diminishing returns, when I think about that point, in terms of calculus, the point of diminishing returns is the same thing as talking about an inflection point. And so when I look at this graph up above and I start looking at the shape of this graph, our graph is concave up. And remember, concave up means sort of a U shape, an upward U shape, where the tangent lines are below the graph. And right about in the middle, right around the steepest spot in here, right around this point, our graph changes from concave up to concave down. And so from beyond that point, our graph is concave down. If I were to draw tangent lines on this graph, on the green portion, the portion to the left of the dot, all the tangent line, or the graph would be above all of the tangent lines, and after that dot that I have in the middle, on the red portion of the graph, our graph would be below the tangent lines. So I can label this graph as concave up on the bottom and concave down up above. And that point where our graph switches from concave up to concave down, that is our point of inflection, or also known as an inflection point. And in terms of business, that means that this is our point of diminishing returns. Okay, so we found that point. It's the inflection point in terms of calculus. It's the point of diminishing returns in terms of business. One more way to say this is our maximum rate of return. After that point, the rate of the return begins to diminish, begins to decrease. Okay, so that is part B. We're now going to move on to part C, and part C asks us to find the inflection point precisely. Okay, so that means that we're going to have some calculations to do. And what we saw in the first part of the lecture for this section is that we saw that we saw that the inflection point occurs when the second derivative, s double prime, is equal to 0. Okay. When s double prime is positive, the graph is concave up. When s double prime is negative, the graph is concave down. And when s double prime is 0, that's where we will find our inflection points. Alright, so our original function was s of x is equal to negative 0.06 x to the third plus 1.9 x squared plus 5. And we need to find the second derivative. So we'll start by finding the first derivative. So when I take the derivative, there's no product, no quotient, no chain rule required, just a bunch of power rules. So I bring that 3 down. So I have negative 0.18 x squared plus, I bring that 2 down, I have 3.8x, and my derivative of 5 is 0. Okay, so that's my first derivative. And now I want to find the second derivative. And I would encourage you to pause the video and write down your second derivative before I tell you what it is. But here it is. We have negative 0.36x plus 3.8. Okay, so that's our second derivative, and our inflection point is going to occur when our second derivative is equal to 0. So we want to set the second derivative equal to 0. So I have 0 is equal to negative 0.36x plus 3.8. And now I want to solve for x. So to solve for x, I can add 0.36x to both sides. So I have 0.36x equals 3.8. And now I can divide both sides by 0.36. And I end up with x is equal to 10.6. Cool. So this tells me that my inflection point is x equals 10.6. And the way I want to think about this, my interpretation of this inflection point, is that x equals 10.6 is the point of diminishing returns So 10.6 is the point of diminishing returns, and money spent over $10.6 thousand will still increase sales but with less increase per dollar spent. At the value of $10.6 thousand, the investor who is investing money in advertising is going to get the maximum rate of return, the most bang for his or her buck, the most sales per increase in dollar. After that point, this investor will get less sales per dollar invested. All right, So that wraps up the actual problem. I do want to go back and double check that graph that we had. So our inflection point that we found, our inflection point is 10.6. That was our exact value. Let's go back to the graph that we drew at the very beginning. Well, not at the very beginning, but here at the middle, where we estimated on the graph the point of diminishing returns. And what I see here is that our point is right about at 10. So our estimate, based on our hand-drawn graph, is that our point of diminishing returns, or our maximum rate of return, occurs at $10,000. That was pretty close, not too shabby for a hand-drawn picture and an estimate that we're eyeballing. Okay, thanks for listening. Have a good night.